Okay, so today's lesson is we're going to deal with the law of logs. Laws of logs. Laws of logs, yeah. Okay, I'll give you one later today. So what's the base if we don't see it? 10. So when we're asking, okay, 10 to the power of what equals 1,000? We're solving for our exponent. Well, with 10, the nice thing with 10 is we just count the number of zeros. So this is 4, so this would equal to 4. So how about log 10? Okay, so log 10, 10 to the power of what equals 10? 10 to the power of what equals 10? 1 plus 10 to the power of what equals 1,000? 3, so that equals, so 1 plus 3 is also 4. Okay? How about the next guy? What would this guy equal to?
4.
No. Oh, no. This guy here. 6 minus log 100 is, guys? Okay, so they're all equal to 4. And last one, this is going to be 2 times, this is equal to 2, so 4. So they're all the same. And so how come this guy is the same as this? How are they related? Looking at these two numbers here, how is 10,000 related to 10 and 1,000? The number of zeros total is the same. So we could say 10 times 1,000 gives you 10,000. Sorry, 10 times 1,000 gives you 10,000. Okay, how about these two here? What's the relationship? You minus the zeros, okay? So we had 6 zeros and 2 zeros, so we subtract them, right? So it's the same thing as dividing these. So 1,000 so this is 1,000,000 divided by 1,000 gives you what? It gives you 10,000. Trying to see what's the relationship between our guy and the first. Okay? Yeah, so we're going to, from this stems 3 different laws that we're going to focus on today. How am I going to go through this? Oh, yes. The laws of logs are directly related to the exponent laws because they're essentially exponents. So remember when we have the same base being multiplied, what did we do to the powers? Add them. So that's going to relate to logs. So if we look at our logs, there's three laws that we're going to really focus on today. So you might want to have a highlighter or underline. So there's 3 of them we're going to focus on: the quotient law, the power law, and the product law. Okay? So the product law is related in that, remember when we have the same base being multiplied, we add the powers. Well, the product law says if we have a product inside of a log, we can split it up into addition with the same base. Okay, so for example, log 5 times 2,000 is equal to log 5 plus log 2,000. Or sorry, it's a 200. Yes. So we're going to use this when, usually we're going to go from this direction to this direction, because it is easier to express it all as one log. Okay, and we're going to use that to solve for the inside later on. Okay, so this is just the basic version, and we're going to expand upon that in the next couple days. Okay? If the division is happening on the inside, we could also write that as the log of m minus the log of n, always with the same base. So for example, the natural log of 3 over 4 would be the natural log of 3 minus the natural log of 4. It's equal to the same thing. And then last is the power law. So if as an exponent, is here, it goes down to the front. So it would be equal to n times the log of m, b of m. So for example, log 2 of 5 cubed is equivalent to, bringing the 3 down, 3 log 2 of 5. Okay, so those are the 3 rules we're going to practice. Beautiful? So let's actually practice them. Yeah, it's good. So, okay, we have a product. So which law are we going to use? What are we going to do with these? The product, the quotient, or the power? Product. Okay, so for the product, this would become log base, so 5 of 8. And what are we going to do with these 2 logs? Plus them. Plus log 5 of 6. It's another way you can write it. You try the next one on your own. Plus. So it's multiplication here. So log z of x plus log z of y. Okay, the reverse is true. If we have the same bases and these logs are being added, what can we do with all the insides? Add them or multiply them? Multiply them together. Okay, so to bring them all in one log, what would it become? Log of CABIN.
Oh, we got a joke.
There we go. There's one. Log cabin. Okay? There you go. There's a log cabin. There's one. I got 2 for you today. Okay? So that's, yeah, it's good, right? And you didn't expect it. That's the best part. It actually completely fit. Okay, so let's go backwards. What will this become? So writing as a single log. 7 times 5, or you could write that as log 3 of, what's 7 times 5? 35. Okay, so going the other way, writing this as a single log, because the bases are the same, we can write this as log b of SR. Easy, right? It's just practicing to get used to the laws. If your formula sheets, I don't know if anyone has looked at a formula sheet in a while. Where are your formulas? They're usually on your tests, right? Let me just grab a formula sheet. Does someone have a formula sheet on them that I've given you? It's a blue formula sheet. Does someone have that on them? There's one. Nope. Yay, there's one. Okay, so if you have your formula sheet on you, these 3 laws are on the formula sheet, and they will be on the formula sheet for the diploma. This is pulled from the diploma exam. So this is your formula sheet for the diploma. What do you mean? Yeah, it's the same every year. It doesn't change, right? So they want us to give it to you so that you're used to it. Yeah, yeah. I didn't actually steal it. They release it to me. They say, here you go, this is your, pardon me? That's the exact one. It'll look identical. Same font and everything. So you're like, ooh, that looks familiar. It won't be on blue paper, though. Sorry. Just be close to the same. Okay. So separating it as separate logs, what would I do if we have division on the inside? Subtraction. So log 2 of 36 minus log 2 of 11. Try this guy. Log z of x minus log z of y. what's really nice too with these ones is you can do them all in one step. Like I did the log cabin, right? They all have addition in front, so they are all multiplication. So if I had an example, like, let's do 7 plus log 4, 2 minus log 4, 5 minus log 4, 1. Okay? So if I wanted to combine this all under one log, there's a lot of talking going on. Tamara, put that on my desk, please. Okay? Caitlin? Yeah? If there's a different base, we can't combine them. We can only combine ones with the same base. So it's very important that the bases are the same. These rules only work for the same base. Okay? Well, if they don't have the same base, then you can't combine them. You just have to type it in as you see it. Okay? So here, which ones, if I want to write this all under one log, I could do this in one step fairly easily. So who would be on the numerator? 7 times 2, and who would be on the bottom? 5 and 1. 5 times 1. So you can just see, based on the sign in front of the log, if it's going to be on the numerator or the denominator, and this is positive up front. Yeah. The reason why is you could also write it as, so you can factor out the negative here. Guys. Okay, so you can see how, right, if you factor out the negative, you can see how these become, this is a product rule here, so 7 times 2, and this is a product rule here, 5 times 1. And that's where we multiply. Now we have division, so it turns into 7 times 2 over 5 times 1. Okay, so it's a lot more work if I wrote down every step. So we factor out the negative to turn this into a product rule. Yeah. Yeah. Same rules apply for natural logs. Base E, though, if there's no base written. Okay, so what would this guy become? Log 3 of 15 over 11. And log B of S over R. Okay? These are fun. I really love log laws. Okay? Log laws. It sounds like there's a store. Yeah. Loblaws. Okay. So the last one we need to look at is exponential form. And then we're going to give you a question that you're going to try. So the power law the power law says that if we have an exponent on our answer on the inside, where can we bring that exponent, Rachel? Where can I put this exponent with the power law? In front of the log. So this is equivalent to 3 times log 6 of 7. So what would this one be equivalent to? Y times log Z of X. Canadian. Z. Yeah. Yeah. Okay, so this is right as a single log. So I want you to try this next one on your own. Yep. Try the next one on your own. Why don't you try all of these that are below, and then we're going to go over them. Okay, Sawyer, you have to be writing your notes. Oh, no, sorry, buddy.
No, look.
Everything.
They're all right here.
Participate. We're not even on this page.
They're all right down here. I did it with my computer the other day.
Okay. Deal. Okay. Don't know how to do C. Caitlin, circle it and we'll go over it right away. Right is a single log. If you have multiplication or division, simplify the inside if you can. And then it says evaluate, and then evaluate. Get your answer after. So you have to, before you can combine these, you have to put this 2 up here.
Okay, that's what I was thinking. Okay,
And now then you
that's
can use
all.
your
Okay.
laws. Then you multiply them. Okay. Ready to go through some of them? Or do you need more time? A little more time? Okay. Okay, so this guy is going to become 2 times 108, which is equal to, so we're going to evaluate the inside first. 2 times 108 is 216. So 6 to the power of what is 216? So you need this part, and 6 to the power of what is 216? Anyone know? 3. Right? 6 to the power of 3 is 216. You have to guess and check in your calculator. That's how we figure that out. We actually should have memorized the cubes in grade 10, but a bunch of people. I know. Too bad, hey? I feel so bad for you guys. I really do. Okay, so what do we do with this subtraction? What do we do if it's subtraction? Divide 810 divided by 10. What does that equal to? Come on. 81. So you need this part for a single log. 3 to the power of what equals 81? 4. Okay. Okay, sorry. Sorry. Okay, ready to go now? Not yet.
Yeah.
Okay, now here's the thing. The product law and quotient law don't work if there's a number in front of the log. The product law and the quotient law only work if the log's by itself. Okay, so the question is, there's 2 ways we can solve this next guy. How do we get rid of the 2 in front of the log? The power law, the exponent, yeah. So it becomes log 5 to the power of 2 plus log 2 to the power of 2, right? This becomes squared. This guy goes up here to make a square. You can only use your product and quotient law if the logs are by themselves. So this gives you log 25 plus log 4. Now what can we use the product law now? Yes. We have the same base. There's nothing in front of our logs. So it would be log of, what do we do with those 2 numbers? Multiply them, right? Which gives you log of 100. So 10 to the power of what? So there's log 100 is our single log. 10 to the power of 2. So your answer is 2. You did what?
I just combined I just did 2 log 5 times 2.
You typed it in your calculator? No, yeah, but I want you to practice doing it algebraically. Okay? So the other option you could have taken here is factor the 2 out. Okay, there's another option. If you factor the 2 out, then we can use product law here. So 2 times 1. 2. Okay, there's 2 options there. Okie dokie. Smokies. I want you to try this guy now. Now that we just went over, you know you have to have nothing in front of the log. for the log laws to work, try it out. Yep. So who do you have to move first? You have to move the 2. So it's going to become log 3 of 6 to the power of 2, or 36. Okay. Now what's next? So now can we put them all in one log? Yes. So because there's nothing in front of our logs and we're adding them, we're going to do what with our insides? Times them. 6 squared times 0.75. So 36 times 0.75, what does that equal? 27. So there it is, all as one log. 3 to the power of what is 27? 3. That was fun, hey? Yeah? Okay, we're going to try one more. One more. I'll actually give it the handout to you. Because we need something a little bit more challenging. So if you finish early, I have this extra practice. I'm going to decide if I'm going to make it homework or not. Maybe. On top of the other stuff, which is short. Okay, I'm just hold tight. I would every day. Yep. That is pretty amazing. It's a miracle is what that is. I'm getting some help from upstairs. Okay. Oh, anyone lacking one? Does everyone have one?
No.
Okay. Yeah. Here. Okay. So, if you finish early, I want you to try this worksheet. Okay? So this is really practicing what we did yesterday and solidifying those concepts. Number 4, I really love. That is like how they might word a log question as well on the diploma. So do you want to try number 4 and then we'll go over it? No? Okay. Yeah, it's like a puzzle. Okay, so if you finish early, can you please work through this just to review some things? And expect something like this on your quiz tomorrow. Okay, how would I approach this? This is like a quiz question tomorrow. Okay. What would I have to do first? What's the first thing you have to do? You have to get to the 2, and not so much the negative, but the 1/2. Okay? So where is the 2 going to go? Girls? Yeah. Okay, so log 4 of 3 squared minus log 4 of 5 minus log 4 of 10 to the power of 0.5 or 1/2, either or. Okay, so how would I write this as a single log now? Who would be on the numerator? Who would be on the denominator? Who's on the denominator? Numerator is positive, denominator is negative. Okay, so the first guy would be on top. He's positive. The 5, and what would we do with these two numbers? Add or multiply? Multiply. Okay, so that's what that would look like as a single log. Why? It's like you factor out the negative, and we're going to use the product law. Okay, so anything with the negative will end up on the bottom, and everything with a positive goes on top. And then they're either multiplying or dividing on the inside. And then if you wanted to type that in, you could. You'd have to use a whole bunch of brackets. What is 10 to the power of a half really mean? No. How would you write that? How else could you write this?
10 to the 0.5, so half of that.
No. Fractional exponents, what are they related to? Guys, we just covered this last unit. You need to know this. Fractional exponents are related to what? I'm waiting for an answer. Take guesses. You need that last unit for this. Fractional exponents are radicals. Fraction, right? So this is a square root of 10. They're the same thing. Okay, so you're typing in, it's 9 over 5 times root 10. Okay, yeah, it's a random example I came up with. Okay, so your homework is in your workbook first, and it's 7.3 homework. And then if you get finished, you can practice this little guy. And yeah, tomorrow's Thursday and it's a short day, right?